Thank you very much for the introduction. And that's really an interesting question here. Hyper-converged, is this the only way to the software-defined data center? And I'm really happy to be here in Delhi to do this reality check of Hyper-converged together with you. And you know, there is so much talk here at this event and outside in the market about digitalization. And I do not want to waste time with this here and do this chat as well. I just want to say, in the digitalization age, actually, we are faced with an ever-increasing amount of data which needs to be collected, which needs to be transported through the networks, which needs to be processed and analyzed and also be stored. And this has, of course, a huge impact on data center infrastructures, on servers and networks and storage as well. And from a customer's point of view like you, the needs are crystal clear. These infrastructures need to be fast and flexible in terms of scalability because the amounts of data are ever increasing. Then we need resilience. They have to run round the clock. And the whole thing needs to be simple and efficient in terms of operations. And if we compare this with a traditional data center infrastructure where everything is hardware defined and rigid, where management happens in silos for the servers, for the network, and for storage, and admittedly, maybe some operational tasks may be at a certain level of automation, but nevertheless, there is so much to be done manually in terms of operation so that things are becoming slow. So the bottom line of all of this is that traditional data center infrastructures are complex, inflexible, expensive, and they require also skills from the IT organization's point of view. And the question is now, how can we change the game? And certainly there is not the one and only answer, but one of the answers that is heavily discussed in the market out there is hyper-converged infrastructure. And just to be clear, or just to be sure that we are all on the same page and we have the same understanding of what we are talking about here, I want to summarize the most important characteristics of hyper-converged here on this slide. So first of all, we understand that this is a cluster of servers which are interconnected. There is no external storage. That means data is spread across the local disks of these servers in the cluster. We have no physical SAN, but we have a virtual SAN instead that spreads across these servers. Data services are built in. For instance, data replication or deduplication, data compression, data tiering, all that stuff that you know from external storage systems. High availability is built in because if one server fails, there is still another one that can take over the workload. Data won't be lost due to the feature of data replication, so high availability should be guaranteed. Then there is a unified central management for both the compute resources and the storage resources. And another great feature is the scale-out capability in terms of performance and in terms of data capacity, meaning whenever we need more performance or we need more storage, then we just add servers. These servers will be even automatically discovered, and the integration into the existing cluster is very, very simple because everything is software defined. And this means, of course, that there are a number of benefits resulting from these characteristics. As we don't have an external storage, there are less components involved in the overall infrastructure, which means we require less space in the data center. The energy consumption is lower, the cooling requirements are lower, then the administration becomes simpler because one administrator can do the server and the storage stuff, usually lower skills could be sufficient, which means from an organization's point of view that even lower paid staff could do the work. And the great thing, and this results from the scalability capability, is that you can start small and you grow as you go. And this means you can adapt and align your infrastructure very flexibly to the demands of the business, towards the business. You can demonstrate a great responsiveness and, of course, resulting from the built-in high availability. You can ensure business continuity, and what isn't bad either, that the total cost of ownership is usually lower. So this sounds all great, and you could easily come to the conclusion that hyper-converged is the holy grail or the silver bullet of IT. But the question is it this really? And before I want to give the answer, I want to compare both architectures, the classical one and the hyper-converged one, by means of this slide here. So if we consider classical architectures, we do have servers, we have a local area network, we have external storage, we do have a storage area network. That means we have multiple components, and for all these components, lifecycle management is necessary. And unfortunately, of course, the life cycles of these individual components are usually different, which doesn't make things easier. Then there are two separate networks to maintain, the storage network and the local area network. And of course, some of you might say, but of course, the data traffic could also go through the LAN. You are absolutely right, this is possible. So from a physical perspective, it would be only one network, but with regards to maintenance and management, it would be two from a logical point of view. If you regard the hyper-converged side, actually, as we said, storage is included in the servers, so we do have only servers. And the LAN lifecycle management is necessary for less components, but we do need a more powerful local area network because all the storage traffic has to go through the LAN. Classical infrastructures are hardware defined. Here with hyper-converged, the compute resources and the storage resources are software defined. When it comes to scalability, actually, with classical architectures, scalability happens by adding multiple components. Servers, if you need more performance, storage, if you need more storage capacity, and this can happen and will happen primarily separately. With hyper-converged, actually, scalability always means you add servers, and this usually linearly. So that means whenever you need more compute performance, if you want to have a more or less homogeneous server cluster, you will add also more storage capacity. When it comes to the storage activities, well, on the left-hand side with classical, they are totally separated from the servers. They are happening in the storage systems themselves. When considering hyper-converged, actually the servers are of course involved in the storage activities because we do not have an external storage, and this needs to be considered when sizing the compute resources. So when we started our hyper-converged business some 3 years ago, we always said as a kind of rule of thumb that it makes sense to reserve 10% of the compute resources for the storage activities. This was already at that time a very conservative estimation. Nowadays, as the compute resources are much, much more powerful, we think that the percentage is going down and is much less than that. And if we consider the architectures as such and the maturity, we have to say classical has been established for many, many years. We basically grew up with classical architectures. Hyper-converged entered the market, I would say, some 3 years ago, there were first vendors even starting the business already before that, but compared with classical, it's still pretty new. And the question is now, what do these differences mean for you? So the classical architectures actually, they can be used for any kind of purpose. So no matter whether your workload needs to run bare metal on a physical platform, whether it needs to run in a virtual environment, or maybe you need an infrastructure with workloads that require multiple hypervisors, a classical architecture can serve for this. There is a certain kind of hardware dependence here, particularly with regards to the storage. And when it comes to software licensing, I think everybody who is already in the IT business for a couple of years is quite familiar with the software licensing on this left-hand side. When it comes to hyper-converged, well, we have to say at a certain extent, these architectures are less usable for general purposes because virtualization is actually a must. And it's admittedly no hardware dependence there, but there is a software dependence instead, because you need software that is managing all this software-defined compute and software-defined storage. And there may be some sort of commercial restrictions depending on the license policies, for instance, of database vendors. There are database vendors saying, well, you have to pay license fees for every CPU or CPU socket or CPU core where in theory a workload will run. So, and with hyper-converged, depending on the implementation, you do not know on which CPU socket or CPU core this will run. And that's why pretty soon you get into an area in terms of budget that you need for the whole thing, where everything becomes a no-go. When it comes to operational complexity, we have to state, well, hyper-converged, the complexity is definitely reduced. When it comes to CapEx, we have to say that on the classical side, the hardware costs are usually higher because we need an external storage system. The software cost will be lower, and with hyper-converged, it's actually vice versa. Hardware becomes cheaper, you don't need an external storage, but instead you have to pay license fees. And there is not a general rule that you can say the overall CapEx is cheaper here or there. It usually depends on the use case, and at the end of the day, we'll have to make a CapEx comparison. And just a short remark with regards to the vendors. With classical, actually, it's mainly the well-established vendors. With hyper-converged, we have a lot of newcomers in the market, but meanwhile, I guess all the established vendors are also playing the game. And this means basically that both approaches provide a couple of unique advantages. So here with classical, it's actually the general purpose for which we can use it. With hyper-converged, it's definitely the lower operational complexity that is really attractive for customers. Some of you are now wondering, so what is now the better solution or the ideal solution for my particular use case? And as I said already before, there is no black and white answer. But what I can give you at hand here is a couple of aspects that need to be considered. So first of all, it's all about the workloads. So if your workloads need scale out, then certainly hyper-converged is a good way to go, because here we have this great ease of scalability, especially if compute and storage needs scale in tandem. A prime example for this is virtual desktop infrastructures. You know, if your end users that you virtualize have more or less the same requirements in terms of resources. If you want to add 100 virtual desktop users more, it's fairly simple just to add a server or two, depending on the user profile, and that's it. But if it turns out that your workloads actually need scale up, if they need a granular expansion on the component level, maybe today you need some more CPU performance, tomorrow you need some more storage capacity, then certainly there is much that speaks for a classical architecture. Then it's about the expected growth. So if you have to grow your infrastructure every now and then, or every couple of days, then ease of scalability is certainly a point for you that is relevant, and then hyper-converged could be the better way to go. If there is hardly any growth, or only a growth every leap year, then probably you can't take advantage from hyper-converged. Remote offices and branch offices, rather independent from the workload that is running. There are more and more customers saying, well, in the past I had a storage area network in my robos, and this caused so much headache for my administrators in the data center. It cost so much travel time and travel expenses. So we want to get rid of the storage area network. We implement hyper-converged infrastructures which can be managed from a central point, and that's it. Mixed operation. Well, as I said before, if bare metal operation is needed, for instance, SAP HANA is a prominent example. Though SAP is working in their labs on running SAP HANA on hyper-converged, currently it is not running, so for this you need basically a traditional architecture. Then the question is, do the workloads benefit from the built-in data services? If they do, you could say, oh, that's great. Then I get something for free that I need anyway. But if it is the other way around, if they do not benefit, then you could say, well, then I pay implicitly something for things that I don't need. So it's always a matter of consideration. And then the question is, does your organization really benefit from the unified management of compute and storage resources? There is no doubt about it. So management becomes easier. But is your organization prepared for it? There are existing skills in your organization, and if you tell the storage administrators tomorrow that you don't need them anymore, there might be some resistance, and the question is, do you really want to face with this resistance? So are the staff roles really ready for this change? And then it's a question of the storage strategy. There are customers saying, whenever I introduce something new, then I want to use a special sort of storage that I once implemented in my company. Then hyper-converged is probably not the ideal way that fits to this strategy. If the customer instead says, oh, these external storage systems cause so much headache, I want to get rid of them sooner or later, well, then hyper-converged could be a good start. And we also should have a look at the storage capacity. So basically today, every hyper-converged solution is limited in terms of number of server nodes. And with every server node, of course, also the storage capacity is limited. And the question is the overall storage capacity that you have to deal with, is it larger than what your hyper-converged solution supports or not? So, and resulting from this, I think it's also very clear which way to go. We were talking already about software licensing. So this is a very important thing that needs to be considered, because it really has a huge impact on the capital expenditure here. And as I said before, a CapEx comparison is pretty often the thing that has to happen before a project really starts. So this means, and this is the recommendation that we usually give in general to our customers, the decision should take place per each use case. We recommend to go for hyper-converged if the benefits outweigh the drawbacks, but at the end of the day, it's the use case that really matters, and that's why it's important to support both architectures. And hyper-converged is definitely a great springboard towards the software-defined data center. The software-defined data center means we do not just have software-defined compute and storage resources, also the network resources are virtualized, so a virtualized everything scenario which can be deployed on any hardware where the components are interchangeable and where management becomes even simpler compared with hyper-converged, because the network is also managed in a unified way. Automation, not only for operation but also for provisioning and for configuration, is here actually a given, where resource orchestration happens based on policies. And as I said, hyper-converged is a great springboard to software-defined, but it's not the only one. It really depends on the use case. And if in both cases you add a self-service portal and metering and charging functionality to this, basically you turn your software-defined data center into one with cloud capabilities, and all that stuff makes your infrastructure simple, fast, flexible, efficient, which is exactly the right answer to digitalization. And the question is now, when you have once found the answer to the question hyper-converged or classical, how to get your infrastructure up and running. And doing all of this in a do-it-yourself approach is probably not the best recommendation, because it's time-consuming, risky, and expensive. After the project start, you first of all have to select the right components from a myriad of software and hardware products. You have to do the integration of the components. You have to work off a very complex test matrix, because the compatibility of the individual components is not always ensured. And only after having done this, you start with the on-site deployment and the integration into the production environment. And of course, there is an easier way to go, and this is integrated systems, where all that stuff such as designing the infrastructure, component integration, and testing has been done by the vendor before the project even started. So the project is basically limited to the on-site deployment and the integration into the production environment. And this actually brings me to my company Fujitsu, brings me to Fujitsu integrated system PrimeFlex, which is a pre-configured, pre-integrated and pre-tested combination of all these data center components, which helps you reduce complexity, time, risk, and also cost, which also helps you increase the operational efficiency and gives you time to focus more on the really important things of the business rather than looking after building an infrastructure. And just to take with you a couple of characteristics of our PrimeFlex family. So important to state that PrimeFlex includes the classical type of converged systems and hyper-converged systems. That means if you speak with us, we have no reason to push you into a certain corner because we do one or the other better than the other. So it's really our approach to collaborate together with you in a kind of co-creation process, the ideal solution that is optimum for your use case. There are standard sizes that we deliver ready to run, but we understand that one size does not fit all in many cases, so customizable reference architectures is also part of the portfolio that can be flexibly adapted to your customer-specific environment. And all these offerings are based on best practices and project experience, based on our own technologies, such as PrimeFlex servers, for instance, but also on partner technologies. And of course, it's worth mentioning that PrimeFlex should not mean just boxes. It should be supplemented by flexible services options. And here we also count on our local partners that go together with us onto this journey. Just that you know on which areas we focus with our PrimeFlex portfolio. It's basically 5 use case areas. I want to have a look only at the virtualization area, because we are talking converged or hyper-converged. And I hope that this slide gives you a certain indication of how our 5 virtualization offerings are here positioned. Here on the upper half of the slide, you see our hyper-converged offerings. On the left-hand side, those which are based on VMware technology. On the right-hand side, those which are based on Microsoft technology. And here on the lower half of the picture, you see our PrimeFlex V-Shape, which is a classic converged architecture where we give customers the choice between VMware and Microsoft. And yes, what you see here is a couple of figures that give you an indication on what is the maximum number of server nodes in these configurations. So you see what is outstanding here is a pretty new product, which is PrimeFlex for VMware Cloud Foundation, which goes up to 192 nodes. What is worth mentioning here is that it's not only software-defined compute and software-defined storage. It includes also the software-defined networking stuff, which means it is a fully fledged software-defined data center based on a hyper-converged architecture and VMware technology. I do not want to go into further details. I just want to remind you of the fact that our virtualization offerings are based on PrimeFlex servers from Fujitsu, and these are the absolute world champions in terms of virtualization performance. The vMark benchmark is seen as the de facto standard in these benchmarks areas, and you see here in the last 5 to 6 years we have covered the world championships in most of these categories, and not only at a certain point in time. Whenever you see red here on this slide, it means Fujitsu has been the world champion in this area. And as the headline of my presentation is about software-defined data center, I should also give you an indication which fully fledged software-defined data center options we provide. We discussed already the hyper-converged flavor, the PrimeFlex for VMware Cloud Foundation a minute ago. If you rather want to go for converged, if you want to go for an OpenStack, an open source-based thing, we can help you out with PrimeFlex for OpenStack, where we again give you the choice between the 2 main distributions in this area, which is Red Hat and SUSE. And this brings me already to the summary of my presentation. So what are the most important takeaways? So I think there is no doubt about it that hyper-converged is a rising star in today's IT market, because there are so many benefits, and these benefits are convincing. And it is true, it is a springboard to software-defined data center, because you only have to add software-defined networking and that's it. But hyper-converged is not the only way to go. I hope I could bring this across. The use cases matter here, but no matter whether classic converged or hyper-converged is the right way to go, integrated systems will help you to reduce complexity, time, risk, and cost, will also help you increase operational efficiency. And with the integrated systems from my company, Fujitsu, which is PrimeFlex, we provide choice. We provide choice in terms of classical converged and hyper-converged, which means that we can elaborate with you in a sort of co-creation the ideal solution for your use case. So what I can only say at the end of my speech is, if you are wondering if hyper-converged is your way to go into the future, just have a word with my company, Fujitsu, and I'm sure we will bring you on the right track. Thank you very much for your attention.